Splitting a wire in an electrical panel to fit the lug size, even if you go one wire size bigger than required, poses several threats. Firstly, overheating is a significant concern. Splitting a wire reduces its cross-sectional area, effectively increasing its resistance. Increased resistance generates more heat during current flow, potentially leading to overheating and degradation of the wire. Secondly, splitting a wire effectively reduces its ampacity, which is its current carrying capacity. This can overload the wire and cause it to fail, posing a fire hazard. Thirdly, mechanical failure is a risk. Splitting a wire can weaken its mechanical strength. The split sections may be susceptible to breaking or pulling apart, leading to open circuits and electrical faults. Fourthly, the exposed surfaces of split wires are more prone to corrosion. This can further reduce the wire's conductivity and increases resistance. Fifthly, if the split wire is not properly insulated, it can create an electrical shock hazard. The exposed conductors may come into contact with conductive surfaces or other wires, creating a pathway for current flow. Sixthly, in the event of a short circuit, the split wire can experience an arc flash due to its reduced ampacity. This can release significant amounts of energy in the form of heat, light, and shrapnel. It is important to note that going one wire size bigger does not eliminate these risks, as the reduced cross-sectional area of the split wire still affects its performance. Splitting wires is generally not recommended and should only be done as a last resort in emergency situations where it is not possible to obtain the correct wire size. Proper wiring practices, including the use of appropriately sized conductors and properly terminated connections, should always be followed to ensure electrical safety and reliability. To elaborate further on overheating, consider that the heat generated in a conductor is proportional to the square of the current and the resistance of the conductor, as described by Joule's law. By splitting a wire, even if you increase the overall gauge, you are still effectively creating a point of high resistance at the split. This localized increase in resistance will lead to a concentration of heat at that point. Over time, this can degrade the insulation of the wire, leading to shorts, ground faults, and ultimately a fire. Regarding reduced ampacity, the National Electrical Code, or NEC, provides tables that specify the ampacity of various wire sizes based on their material, insulation type, and installation conditions. These ampacity ratings are determined by the wire's ability to dissipate heat without exceeding its maximum operating temperature. When a wire is split, its ability to dissipate heat is compromised, effectively reducing its ampacity. This can lead to the wire being overloaded, even if the current flowing through it is below the ampacity rating for the original wire size. As for mechanical failure, wires are designed to withstand certain tensile forces and bending stresses. Splitting a wire introduces stress concentrations at the split, making it more susceptible to breaking or pulling apart, especially under vibration or physical strain. This can lead to an open circuit, which can disrupt the flow of electricity and potentially damage equipment. Concerning corrosion, the exposed copper or aluminum of a split wire is more vulnerable to oxidation and other forms of corrosion, particularly in humid or corrosive environments. Corrosion increases the resistance of the wire, further exacerbating the problems of overheating and reduced ampacity. Electrical shock hazards are also amplified by splitting wires. If the insulation on a split wire is compromised, it can expose live conductors, creating a risk of electric shock if someone comes into contact with them. This is especially dangerous in wet or damp environments, where the resistance of the human body is reduced. Arc flash hazards are a serious concern in electrical systems. An arc flash is a type of electrical explosion that occurs when a short circuit creates a high energy discharge. The heat, light, and pressure produced by an arc flash can cause severe burns, blindness, and even death. Splitting wires increases the risk of an arc flash by reducing the wire's ability to handle fault currents. In the event of a short circuit, the split wire may vaporize, creating a highly conductive plasma that sustains the arc flash. It is crucial to adhere to proper wiring practices to mitigate these risks. This includes using appropriately sized conductors, properly terminating connections, and ensuring that all electrical work is performed by qualified individuals. When making connections in an electrical panel, use appropriately sized lugs that are designed to accommodate the conductor size being used. Never split a wire to make it fit into a lug that is too small. If you need to connect multiple conductors to a single point, use a listed and labeled connector that is specifically designed for that purpose. When selecting conductors, consider the ampacity requirements of the circuit, the environmental conditions, and the directing factors specified in the NEC. Overloading a conductor can lead to overheating, insulation failure, and fire. Proper termination techniques are essential for ensuring reliable and safe electrical connections. Use appropriate crimping tools and connectors to create secure mechanical and electrical bonds. Avoid over-tightening or under-tightening screws, as this can damage the conductors or create loose connections. All electrical work should be performed in accordance with the NEC and other applicable codes and standards. Only qualified individuals who have been properly trained and licensed should perform electrical work. When working on electrical systems, always de-energize the circuit before beginning work. Use appropriate personal protective equipment, such as insulated gloves, safety glasses, and arc-rated clothing. Regular inspections and maintenance of electrical systems can help to identify and correct potential hazards before they lead to serious problems. Check for loose connections, damaged insulation, and signs of overheating. By following these precautions, you can help to ensure the safety and reliability of electrical systems. To delve even deeper into the implications of splitting wires, let's consider the impact on voltage drop. Voltage drop is the reduction in voltage that occurs along a conductor due to its resistance. Excessive voltage drop can cause equipment to malfunction or fail to operate properly. Splitting a wire increases its resistance, which in turn increases voltage drop. This can be particularly problematic in long circuits or circuits that supply sensitive electronic equipment. Furthermore, splitting wires can create imbalances in three-phase systems. In a balanced three-phase system, the current in each phase is equal. However, if the wires are not properly sized or if they are split, the current in each phase can become unbalanced. This can lead to overheating of transformers and other equipment, as well as reduced efficiency. In addition to the technical considerations, there are also legal and insurance implications to consider. Performing electrical work that is not in accordance with the NEC or other applicable codes can result in fines, penalties, and even criminal charges. If a fire or other electrical incident occurs as a result of improper wiring, your insurance company may deny coverage. It is therefore essential to ensure that all electrical work is performed by qualified individuals and in accordance with all applicable codes and standards. When working on electrical panels, it is important to be aware of the potential hazards and to take appropriate precautions. Electrical panels contain live electrical components that can cause serious injury or death if contacted. Always de-energize the panel before beginning work and use appropriate personal protective equipment. If you are not comfortable working on electrical panels, hire a qualified electrician to do the work for you. In summary, splitting wires in electrical panels is a dangerous practice that can lead to a variety of problems, including overheating, reduced ampacity, mechanical failure, corrosion, electrical shock hazards, and arc flash hazards. Always use appropriately sized conductors and properly terminated connections to ensure electrical safety and reliability. When in doubt, consult with a qualified electrician. The NEC provides comprehensive guidelines for safe and effective wiring practices. Familiarize yourself with the relevant sections of the code and follow them carefully. Regular training and education are essential for staying up to date on the latest electrical safety standards and best practices. Attend seminars, workshops, and online courses to enhance your knowledge and skills. Remember, electrical safety is everyone's responsibility. By taking the necessary precautions and following proper wiring practices, you can help to prevent electrical accidents and ensure the safety of yourself and others. The consequences of improper wiring can be severe, so it is always better to err on the side of caution. If you are unsure about any aspect of electrical work, seek the advice of a qualified professional. In addition to the points already discussed, it's important to understand the role of wire connectors and their proper application. Wire connectors are designed to create secure and reliable electrical connections between two or more conductors. There are many different types of wire connectors available, each designed for specific applications. Using the wrong type of wire connector can lead to loose connections, overheating, and other problems. When selecting wire connectors, consider the size and type of conductors being connected, the environmental conditions, and the ampacity requirements of the circuit. Use only listed and labeled wire connectors that are approved for the intended application. Follow the manufacturer's instructions carefully when installing wire connectors. Ensure that the conductors are properly stripped and inserted into the connector. Tighten the connector securely, but do not over-tighten it. Inspect wire connectors regularly for signs of corrosion, damage, or looseness. Replace any damaged or corroded connectors immediately. Proper grounding is another essential aspect of electrical safety. Grounding provides a path for fault current to flow back to the source, which helps to trip circuit breakers and prevent electrical shock hazards. Ensure that all electrical equipment is properly grounded in accordance with the NEC. Use appropriate grounding conductors and connectors. Inspect grounding connections regularly for signs of corrosion or damage. The NEC specifies the minimum size of grounding conductors based on the size of the ungrounded conductors. It also specifies the methods for bonding metal enclosures and equipment to the grounding system. Surge protection is another important consideration for electrical safety. Surges are transient overvoltages that can damage or destroy electronic equipment. Surges can be caused by lightning strikes, power grid switching, and other events. Install surge protected devices, or SPDs, to protect sensitive electronic equipment from surges. SPD are designed to divert surge current away from the equipment and safely to ground. There are many different types of SPD available, each designed for specific applications. Select SPD that are appropriate for the voltage and current levels of the circuits being protected. Install SPD at the service entrance, at subpanels, and at individual equipment locations. Inspect SPD regularly to ensure that they are functioning properly. Replace SPD that have been damaged or that have reached the end of their service life. Electrical inspections are an important part of ensuring electrical safety. Regular electrical inspections can help to identify and correct potential hazards before they lead to serious problems. Hire a qualified electrical inspector to inspect your electrical system. The inspector will check for loose connections, damaged insulation, overloaded circuits, and other potential hazards. The inspector will provide you with a report outlining any problems that need to be addressed. Follow the inspector's recommendations and make any necessary repairs or upgrades to your electrical system. In addition to the technical aspects of electrical safety, it is also important to educate yourself and others about electrical hazards. Teach children about the dangers of electricity and how to avoid electrical shock. Post warning signs in areas where there are electrical hazards. Be aware of the signs of electrical problems, such as flickering lights, sparking outlets, and burning smells. If you suspect an electrical problem, turn off the power to the affected circuit and call a qualified electrician. Remember, electrical safety is a continuous process. By staying informed, following proper wiring practices, and taking appropriate precautions, you can help to prevent electrical accidents and ensure the safety of yourself and others.